Hi folks, and welcome to your first discussion post in Math 222. What I'd like to do is to get us started, I'd like to show you a couple of neat features that we have here for you in the discussion post itself, in the introduction to the post. If you took Math 221 with us, you probably remember this, but let me remind you of a couple things here as you go through, and hopefully this will make your discussion post a little easier. So this is the week one discussion post. When you're on the home page, you'll see the discussion listed under the things that we've asked you to do for the week. And as you start reading through this, you'll notice here and in each one of your discussion posts, you'll see the word example in the statement of the discussion post, and you'll see that there's a hyperlink here. Now I'm not going to open this for you here because I don't want it to ruin this video. But if you click on the example, what you're going to see is first of all a real nice template on how we want you to set up each particular discussion post. You'll also see how we've asked you to use the keywords for the week, and also some exemplary work on how to approach the problems that you've asked or been asked to address for the week. So I would ask, or I would highly encourage you that each week when you go in here and start working on your discussion posts, that you take a look at the example for each week, and that'll be helpful. For this week, we're going to talk about rational expressions, and if you remember the idea of rational numbers, well, as you might expect, you see something involving a numerator and a denominator. And the key concept for the week is understanding what values of the domain make a rational expression undefined. And let me just, I'm assuming you've gone through the reading and you've gone and started doing some of your homework, but let me just recap what we're talking about here. What you remember about rational numbers is that any time that the denominator of a rational expression or a rational number, if you've written a number as a rational number, we know that whenever the denominator is zero, we essentially go outside the real number system. So we always want to avoid a rational expression having a denominator of zero. So let me just take a look at one of these or a couple of these, and let me just give you a couple hints. Again, this kind of goes along with your reading and everything else you've done leading up to this point. So let's take a look at this first one here. So if you're assigned number one and you've got this one, I'm going to give you a little hint here. Again, what we're trying to do is we're going to try to find the numbers, or we are going to find the numbers that make this rational expression undefined. And that expression is undefined when the denominator, in this case, minus 11a, is equal to 0. So the best approach always on a rational expression such as this is simply taking the denominator, in this case, minus 11a, and setting it equal to 0. So if I had minus 11a equals 0 and I solve for a, well, I would find that a is also equal to 0. So the bottom line here is that this particular rational expression is defined, meaning that whenever I substitute a value of a, it will produce a real number as long as a is not equal to 0. And that is a pretty straightforward example. Let me find another here that's, let's see, even a bit more revealing. It was one I saw down here a minute ago, and here it is right here, number 37. So in this case, 9m squared minus 4 over 23. If I set 23 equal to 0, well, first of all, there's no variable, and 23 is not equal to 0. So the bottom line here is that any real number or any number that I substitute for m results in 9m squared minus 4 over 23 becoming a real number. So this particular expression is defined for all real numbers. Here is, let me go to something that's a bit more challenging, and it will take you back to week 5 of Math 221 if you took that with us. Let's look at number 41, and let's look at 2x minus 8 over x squared minus 7x plus 10. What you're going to recall from the last week of Math 221 is that if I take x squared minus 7x plus 10 and set it equal to 0, well, the first approach to solving this takes you right back to the key thing that you learned in that final week of Math 221, and that's how we factor second-degree polynomials. So just sort of as a hint here, what you're going to want to do on something of this form in the denominator where you have a second-degree equation or second-degree polynomial, I should say, when you set it equal to 0, you know that you're going to have to solve this. You're going to have to solve this aspect of the rational expression by setting x squared minus 7x plus 10 equal to 0. I think if you look at that very quickly, I think you see that that factors to x minus 5 times x minus 2. And if each of those factors is set equal to 0, I think you find that if x is 5 or x is 2, then we have a situation here where the entire expression is undefined. So that's, again, the basic idea of what you're doing this week. And again, what it does is it takes you right back to the final week of Math 221. So it shouldn't be a big jump from the final week of that course to the first week of this course. And again, let me remind you what I hope that everybody does before you get started on these. Obviously, again, you've gone through the homework, you've done the reading, you've done everything else that leads up to this. But please take a look at this example. There, again, there'll be an opportunity to view one of these for each discussion post each week. Take a look at that. It's very good in terms of setting up the structure of the discussion post. It's also very good at showing you how we want to use the language, and the language here is probably, I'd say it's probably the most important thing in terms of concepts and understanding how to use the language. If you understand the language, if you understand the concepts, you can do the math. And then finally, it'll give you a good example, 2 good examples of how to approach these rational expressions and finding the domain or finding the values that should be excluded from the domain to make the expression a real number. So I hope this is helpful, and I will do one of these for each week to remind you of the example and kind of highlight the key points of what we're trying to get at each week, and hopefully that's beneficial as you get going on these discussion posts. So have a great week. If there's anything I can do for you, please let me know. And let me also say this. Once you post your initial discussion, within a day, certainly within 48 hours, but most often within a day, I will have looked at your discussion post. I will have given you feedback. And if I've asked you to update your discussion post, please go back and do that because I want everybody to get full credit on these. First of all, I want to make sure you understand what it is you did wrong, and I want to give you a chance to correct that work. But I want to make sure everybody gets full credit. So make your post within a day or 2. Go back and look to see what kind of feedback I've given you. If I've asked you for an update, go ahead and make that update, and we will continue through all the iterations, and we'll make sure that everybody's squared away on the work and everybody's getting full credit. Have a great week, and if there's anything I can do for you, let me know. Take care.